Hello, everyone. This is Doug Neverman, and I'm going to process the M33 data. There's been some questions over the last week about some of the steps that I did, and so I thought I'd put this together. I'm also here with Mark Jobe, who will break in if he feels there's something I'm missing or something that needs to be said. So with that, what we're going to do is I'm going to give you the workflow that I recommend for beginners, and process the data that we made available. And this is data that was taken on the MOS imaging system down in Cherry Grove. So the first thing that I'm going to do is actually the first thing we should do is to make sure the ribbons that we have here with all these icons are the same. So let me bring up, and I did a right click on this area up in here to and have these items checked. So this is what appears up on this screen, top of the screen, and I will be using some of these to get some work done. Some of these also, the position readout and information, are actually down in the bottom ribbon. So you might want to go in and as I say, just right click on this area up in here, and then select and unselect the ones that you want and don't want. So with that, let's get started. The first thing that I do is to do a blink. So you go to Processes, All Processes, and then down here is Blink. And this allows us to look at all of the images. So I'm going to click this icon down here, which gives me the directory, and I have all of the raws in here. So I'm going to select all of these and open them. It'll bring it all into this list, and then there'll be a display of them once it gets done loading. I think I'm loading 34 files. Once that's done, you might want to go up and click this automatic histogram to all images, because what Blink does is to all of them. Not all images are created equal, so some of them will look strange when they really aren't. They just need to be stretched individually. So I recommend that. Okay, yeah, we're doing this over Zoom. I'm doing the presentation and Mark is recording, so we may have some glitches like this. At what point do I need to start, Mark? Got it. So what Blink does is to apply the stretch for the first image to all the images in this list. Not all images are created equal. So what you want to do is to do an automatic histogram transformation on all images. That'll then do it individually so that they all kind of are this. They all have their own individual stretching. Otherwise, you may throw out an image that is actually pretty good. Once you get that done, now see, why does it do that? This is the way it works in all demonstrations. There we go. The next thing you want to do, you want to look at these individually, but we'll run through them. I'm going to set this to a half a second. And then there will be a play. This is a play. When I hit it, it'll start to play through all of these. And you'll see all of the images changing, and we can get a look at them. There's one, if you saw it, with a satellite that went through it. And through this, we can kind of pick out the images that we want and we don't want. And then when you find one you don't want, and let's take There's the one with the satellite. It's one before this one, so I'm going to click that one, and you can see the satellite going through right there. Some people will throw this particular image out. Some will keep it. The WBTP does a pretty good job of taking this out. You may see a little bit of artifact in there if you keep it. For me, I have enough images here that I think I can throw that one out since it's the only one. And what I'm going to do is I'm going to check mark that, and you'll see that as we play through, it'll skip this particular one and not display it. So now you can look at all the ones that you believe are all the other ones and figure out. Now you'll notice that the images are jumping around. This is because the system is set up with a dither, and it automatically moves between pictures. It'll move the telescope just a little bit, and this is a good thing because it prevents any hot pixel or a pixel that is having trouble affecting one point in the sky all the time. It just kind of moves it around. What it does mean, though, is that when we start to put all of these images together in one, that we have to align them. All right, I'm going to stop the play. And so all the ones that are checked are ones that we're going to keep. So I'm going to select them all. So I select the first one, hold the Shift key down, click that one, and then I'm going to hold the Control key down and click that one. So all the ones that are highlighted, that are in orange, are ones that are going to be saved, and that's done down here. So this particular icon is copy the files to a new location. So I can click that and then go up into actually where I have my lights, and I'll create a new folder. Linked again because I've done it a couple times, but in practicing, select that folder. Select that folder. I had to make it, and then I selected it, and you'll see the process console over here doing stuff. It's actually telling you what it's doing. It's covered up by this, and it's difficult to move the dialog box aside while that's happening. So all of those files are now copied over. That those are the ones that we have accepted. So I can close this, and I have to close this also. So having the images selected that we want to do, we're going to do something under script, under batch preprocessing, called weighted batch preprocessing. And what this will do is a whole bunch of things that you would have to do individually if you didn't use WBTP, commonly called WBTP. And what we're going to do is to add darks. We can add biases if we have them. For this particular sensors camera, I don't have biases. I find biases on a CMOS camera to be to not really help, and in some cases hinder. I don't know whether that's just the CMOS or it might be me. It might be the bias files. They may not be short enough. So for this set of images, I don't have any bias. I do have darks. So let's go up to Images, Darks, and we're going to add all of these darks. We also have flats. Images, flats, and we need to add our lights, which will be under Images, Lights, linked again. Let me do a Control A to get all of those and do an Open. So now all the files, all the light files are in here. They're going to be calibrated by these flats and these darks. Let me go back to lights here. One of the things that you should make sure you have right is the, excuse me, the Bayer mosaic pattern. Most cameras are RGB, so leaving it at this value will probably be the right one. We do have a camera down in down on the CGO systems that is BGRG. So if you get any pictures off of the plane wave, that's what you would be using. The next thing you need to do is to come down here and select an output directory. And I'm going to go up here, and we can make a new directory. There is WBTP, which is a directory that I had done this before. And so we can select that folder. And then what you would do is to click Run. Now this takes a while to do. And rather than creating any dead time, we're just going to say, pretend that I ran it earlier today, so that we don't have to watch it do its processing, because this will take, even on my computer, several minutes to get done. So we're just going to exit out of this. Rather than run it, we're just going to exit out and say, yes, we really do want to exit. All right, so at this point, we've taken all of our darks and all of our flats to calibrate all of our lights, and we've taken all of our lights, we've registered them so that all of the stars are lining up, and then stacked them, and we have basically one image. So we're going to open that image. It is in the directory that you specified. So in our situation, we specified the WBTP directory, and under master, you will see 3 files. You can ignore these. These are some JPEGs from earlier processing that I've done. You'll see the master dark and the master flat. The one you want to double click or select open is this one that says master light. So I'm going to double click that, and it will open it up. There we go. Now we actually get 3 files. We get an integration. If you look in here, there's an integration, there's a rejection low, and there's a rejection high. Now we can get rid of the rejection high, but we're going to hold on to the rejection low for a little bit. I'm going to select this, and this is our stacked image. So this is all of the lights stacked together, and this is very common. You wonder where your object is, and it's kind of in there. You can see a bit of the nebula, the core of the galaxy of M33 right there. The objects we look at are very, very dim, not much brighter than the background, and so this is normal, unless you do like something like M42, which is a very, very bright object. So the problem is, at least until we stretch this and make it more permanently brighter, we need to work on some stuff in here, but we need to be able to see it. So if we go to processes, all processes, and we go to screen transfer function, you'll get the dialog here. And there's a button right here called auto stretch. It's the nuclear button, if you hear anybody refers to that. So with this image selected, if we hit this nuclear button, it'll stretch this, so all of a sudden we get to see a whole lot of stuff, and a whole lot of stuff that we really don't like all of this green. Now the reason it's green is, well, there's a green gradient in it that we're going to have to remove at some point. The difficulty is that, well, this green doesn't make it easy to see stuff either. But if you'll look down in here, there's a chain here with 2 links. Right now, all of the RGB channels are linked, and it assumes that the color is balanced, but it's not. So let's, if we click on that to unlink them. So now it's not highlighted, and we do this again. Now all of a sudden we get something a little bit easier for us to look at. Now, I mentioned earlier, as in Blink, that we saw the picture being the frame of the field of view moving around, and that creates some artifacts in our image, and we'll be able to see them here. So I'm going to take, first of all, I'm going to stretch this. I'm also going to make it bigger. This will zoom a little bit, zoom to fit, so it'll make the picture, the window a little bit bigger. And I'm going to zoom in, and I'm doing that by using my mouse wheel. And you can see that there's some scroll bars here. And if I scroll over into the corners, you can see these artifacts here, where this is dark, this is not. These are basically stacking artifacts from the WBTP process, and because the images don't line up. So as it figured out where the stars are, it moved all of the frames around to get them lined up, so that when we stacked, we didn't get double stars or triple stars or 33 stars, like in this case. We need to remove these artifacts. Now, we really don't care about these artifacts on this rejection low image. We do care about the artifacts. Those same artifacts are sitting in this image. If I were to zoom in, you really can't, you can kind of see it a little bit if you know what you're looking for. As it gets closer to the edge, it looks a little bit noisier. But you really don't know, and over here it's more evident, but you really don't know the extent of those artifacts down into your picture. So what we need to do is to define a crop in this image and then apply it to that. So that's what we're going to do. And we do that with a process called Process All Processes Dynamic Crop. With this image selected, then, let's click that, and let's make this zoom to fit so I can get it big. You can see that I can draw a rectangle in here, defining the crop. This is what's going to be kept when we do a crop. And then I can go in to zoomed in and then panned up to the top and the bottom, and I can look at where these edges are. And at least for the moment, knob. Yeah. If you go too far, then this is to rotate it if you want. I'm not sure what it does there, if anything. Oh yeah, you can move it around, but I'm moving the edges, so yeah, you want to wait for that little knob down there. And then we can do this side. So now we have a definition of this area doesn't have any stacking artifacts in them. Now again, it said what you want to do is to not apply it to here, but apply it to here. So over here, on the dynamic crop is a little triangle. If I hold over there, it says new instance. And I'm going to grab that, I'm holding the mouse down, and I'm going to drag it down to here. That means that the definition that is this cropping area is defined in this process. So now I can get rid of this and say yes, cancel it, and I don't need this anymore, and I have this process, and I can take this and just drop it right on top. And if you look at the edges, as I drop it, you can see that it's become smaller. So we took that, we defined the crop in the low rejection image and then applied it to here. I'm going to click this, and then we really don't need this dynamic crop process anymore. Now, the next thing I'm going to do is to change this name. This is a really long name and can make some things difficult sometimes. So I'm going to change this identifier to M33. That's all you do. You go up to here, you do a right click, and you select identifier, and then type in your new name. So that makes life just a little bit easier. All right. So what do we do now? We're going to do. I'm going to link the color channels again, and I'm going to turn this on. And this green stuff is basically a gradient. And we're going to take that gradient out. And the process, all processes we're going to use to do this is automatic background extractor. And we're going to change, if you notice, these gray areas here are different headers when they got double arrows at the end. We can close, these are different sections, and we can close them and open them. We're going to open the image correction. We're going to change this to subtraction. Now we need to apply this subtraction to this way. There's really two ways to do this. One is to use the apply button, and it'll do that. The other way is to take this new instance and drop it on top of the image itself. Either one will work. This is the way that I usually do it, because when you end up with multiple windows, you just got to make sure that you apply it to the right one. Out comes two images. This is the background that is extracting. And you can see it's pretty much all green. That's what it's going to take out. And then here, if I stretch this one, you can see that that green stuff is gone. So we're going to just close that one down and move it over here. Excuse me. And so we're going to work with this image now. I'm going to zoom to fit and move it up in the corner. Now, in actuality, I don't like this particular extraction. The problem is we got the galaxy in the center, then we got this dark band around it, and then we got this another band of stuff around it, and this could cause a problem as we go along. I'm going to leave it just so we can see what might happen. There's actually two things that you can do to get rid of this. You could leave this as it is, and then during your during one portion, when you start to darken the background, it would darken this down. It would, but that may also affect some of the arms and colors that are or intensities that are the same value as this stuff. So when you darken this, you would darken that. Another way to do this is using, instead of automatic background extraction, using another process which is similar, called dynamic background extraction. This is probably a half hour's worth of work to explain how to do that. So I'm not going to do that. I'm not going to talk about it. That's what I would use on this. The other possibility is to just go ahead and use this image, and as we go through in different processes, it may take care of, do a better job. But for now, let's just stay with this one, with this result. I'm going to remind you of this several times, but remember that we have a screen transfer function applied to this. Our data really looks like, and I'm going to go up here to this icon, click that. This is what our data really looks like. But again, we can't see much, and we need to see some stuff, so we stretch it for display purposes only. So the next thing we're going to do is, and let me get over to the side here, is to remove noise. All of this variability in the pixels is all based on noise. Some of them are dark, some of them are bright, and this basically occurs of constructive and destructive interference in the light, in the wave properties of photons as they come to us. So we got three tools we're going to do. We're going to apply one of them twice. So the first one that we're going to use is background neutralization. Background neutralization requires a reference image of the background, basically. So we're going to need to find a little piece of the sky here that is a good representation of the background. I think this area right in here. So how do we do that? Well, we do that by defining a preview. And that's this button, this icon right here. If I click this, see my icon has changed, and I can draw a little bit, I want to try to avoid stars, a little preview of the background area. Now when I click this thing in here, which is used to select the background reference image, I can go down, and here's M33 ABE Preview 01. Select that. OK, that gets loaded into here. And then I'm going to drop that triangle on there. And it doesn't look like it did anything. But let's go in here, and we can undo. And I don't know if you can see it or not, but there's a little bit of color that gets removed by doing that. So it has done some of the work of reducing that noise. Let's go back to full size here. And we're done with this one. The next one we're going to do is color calibration. There it is. This one takes a white reference and a background reference. Well, we already have a background reference, so let's select that one. Now we need a foreground or a white reference. We're going to make another preview. Again, click this thing, and then we're just going to take an area there for the foreground or the white reference, and we're going to select it. Hit OK. So there's the white reference, and there's the background reference. Take this and drop it on there, and you can see that the color is now a little more neutral, I guess is what I'd say. If we go in here and undo the color calibration, you can see that it does have an effect. And we're done with that one. Now the next one we're going to do is something called Multiscale Linear Transform. Now we can target any particular different characteristics of the image, but what we're going to work on is the luminance, and then in the first step, and then we'll work on it again using the chrominance. So let's select that to luminance. Now, we don't want to do it to the whole image because this takes a bit of processing. So we really only want to work with a particular portion of it. And to do that, we're going to make a preview, another preview, and we're going to and do this area which has some background and some brighter areas. Now, if you've been watching, as I made preview 1, preview 2, and preview 3, you can see over on the left-hand side that it's been adding these tabs. So we can actually look at those particular areas. And here's preview 3, the last one we did. This is important because we're only going to work with this portion. So with preview 3 selected, I'm going to open up what's called, what do they call it? A real-time preview. I will sometimes use the term a working preview. So if I click this, this now is a picture that is a working preview, excuse me, a real-time preview. So now that anything that I do in this in this dialog will be automatically applied to this particular image. It doesn't apply it to the image to this image at this point, only to this real-time preview. Now, like I said, we're going to look at the luminance first, and we have different layers here. We can add more layers if we want. We can add, I got 8 layers now. And what we're going to do is to start to reduce the noise, the luminance noise, which is basically the variability in the pixel lights, pixel levels, and try to smooth them out in the background. So now the question will be, how much can we do this? So I just added 1, and if you were watching, I can unclick it, and it just basically takes the background and it smooths it out a little bit. It gets all of those values back towards the same in the background. And I can continue to add. So now your question is, well, why do you want to do these all one by one? And why not just do them all? And the answer is that the processing of the image creates artifacts. And if I do enough of these, I can start to see it. But if I'm going to go really a long ways, and you'll start to see these artifacts around the stars. I'm going to go to another one, and it'll get even worse. So those are artifacts that we really don't like and really don't want. So you add enough to soften the background, or to equalize the background a little bit. I take this one out also, but not so much that it starts to affect the stars. And I can still see a little bit about the stars. And usually what I do, once I find a level I want to go to, I will take and change this threshold number. I'll change this one to 1. And then the next one I will change to 2. And this is where I ended up, and I don't see any artifacts and the background is smoothed out. Now, we were working on the real-time preview, so let's, sure. This one? Yeah, I didn't know that. Cool. So you can see what it was and what it will be. Yeah, I didn't know that. That's cool. So let's close that. And now that we have a definition, I'm going to take this and I'm going to drop it on here. I'll give it a few minutes. And if we go in and look at this, I'm going to undo it, and you can see how much of an effect it has to bring all of the background basically to the same level. What it doesn't do, while it's all the same level, we still have this color modeling that's going on, and that's what we want to take care of next. Now I'm going to do something else here, something new. We have this all set up for the luminance, and while I can change it easily enough for the other stuff, I just wanted to introduce this icon down here, which is the reset. So if I do click this, it resets everything back to its original values. I'm going to open up, I'm going to make, I forget how many levels I used, layers, and this time we're going to work on the chrominance. What we did to this image, of course, gets applied to Preview 1, Preview 2, and Preview 3. So let's go to Preview 3, since we don't want to calculate everything for the whole image yet. So Preview 3, click this to get the real-time preview. And now, just the same as we did with the luminance, we're now going to work on the chrominance and reduce that noise. You would probably be able to see a bigger effect if we had a smaller preview. Really what I'm looking for here is not so much what it does to the background. I pretty much know what it does to the background. What I'm looking for now is, well, what are the artifacts that it puts around the stars? Very similar to when we do the luminance. And I'm going to push. Can you? I didn't think you could. Ah, okay. Up here? Oh, yeah. You can see that the color is being modeled out. That's prior, and that's with the definition that we have. How do I get it back to the normal? Got it. Got it. Down here. Yeah. There we go. I'm learning new stuff tonight, too. Thanks, Mark. Again, I'm going to push this beyond the pale. So that you can see what the artifacts are that you really don't want to get. Come on. I'm not having any effect at all. So I'm going to, well, I should wait until there's a little circle up here that says it's processing. So I probably haven't been waiting for this to get done processing there. Now it's done processing, and you can start to see, let's push it another one, the effects of having too much noise reduction and what it does to the stars. At least I'm seeing, bluish halos around this. There's some kind of yellow tunnels that are running around several of the stars. And this is stuff. There's a big blue one right there. I don't know, Mark, can you see this on your side? Let me push it another one. Let me push it another one. When you're doing this at home, it'll be very, very evident. Yeah, it's just not showing up as much. It really shows up a lot here. So you'll see them. They're just like blue halos around stuff. There's a purple one there. There's a real blue one right there. It's just doesn't, you don't like it. So I'm going to start to click some of these off. And it's still there. I can still see it here. You don't want to have those. They're starting to go away now. Let me take off another one. And it's very possible that if you don't realize you have them and you get into a later process, they will show up and really ruin your picture. And then you have to go back to here to take care of that. So I'm going to stay with 4, but again, I'm going to use this threshold 1. I'm going to change this threshold to 2. And I'm going to call that, I'm looking here, but I'm going to call that good. So let's close this real-time preview, go back to our main image, and take this triangle and drop it on the image. All right, it's done. Let's zoom in here so you can kind of see what we did. Let's undo it, and you can see all of the color. Maybe you can't, but I can. You'll be able to see it. There's a lot of color modeling in here, and the chrominance basically graded out in the background. All right, so we are done working with the reducing the noise as the data is linear. First of all, and I'll explain that. Let's get rid of all of these previews, just because we don't need them anymore. So our data still looks like this. And that processing we just did, the last 4 steps, you would not be able to do if you were trying to work it in this image. That's why we did a screen stretch, or a screen transfer function to stretch it to something we could see. We are now at the point where we want to take this data, which is called linear data, and stretch it, which basically means to make it brighter, like this screen transfer transfer function does, and so that we can see the image. So let's turn that back on. And this band is getting worse as time goes on, as we do work. I don't know whether that's it must be from the processing that we've been doing over the last 4 steps, but it certainly is becoming more and more irritating now. Right. I think the reason is, this is just my own thinking, is that the object is so big that the automatic background extraction doesn't get a good idea of what the gradient is in the background, and so it's just pretty dumb in terms of figuring that out. That's where the dynamic background extraction comes in, is because then you can start to define different points. But let's go on with this one. We are going to now take this from linear data to nonlinear data by stretching it. To do that, there are a couple tools to do that, but the one that I primarily use and recommend at this point is the Histogram Transformation. So if we go down here and select M33ABE, you can see a histogram. This is basically a count of all the pixels that are at each different level. The left-hand side being the number of pixels that are at 0, 1, 2, 3, 4, so on and so forth, until you get to the top one, which is all the white pixels. How many pixels are white pixels? And what this transformation does is to say, well, I want to take this set of pixels here, I'm going to make them lighter or darker, depending upon what you do with this curve. So to get a start on this, we're going to take this new instance triangle. We're going to grab it. I'm holding the mouse down, left mouse down. And rather than drop it onto here, I'm just going to drop it onto there. And you can see that it changed the curve. It's moved these triangles around. There's 3 triangles on here. There's a bright point, a white point, a midpoint, and a dark point. And basically it's moved the dark point up a little bit and the midpoint down quite a bit. If you want to know, I am using the mouse wheel to stretch this out, because we'll want to do that. Now, we just don't want to just start applying stuff. We can use the RealTime Preview again And so I click that. This is a real-time preview, meaning that anything I do here will have an effect over here. Now, it looks completely white, and you're saying, well, what's going on? The reason is we're stretching it here, but we're also stretching it through the screen transfer function. So we're going to turn off the screen transfer function. And so now we have this real-time preview with just this stretch that's going on in here. And now we can grab this. I'm going to hold the mouse down, and I can move this around to wherever I want. I'm finding this picture a little bit irritating to work with. I'm going to move this midpoint up a little bit. I'm trying to get this big donut to dim down a little bit without losing too much information around the galaxy. There is various opinions as to what pictures should look like. Opinions, I should say, or maybe I did. Opinions of what the background should look like. Many people will take this background and move it up so that, and then move this down to try to make the background as black as possible. There are people that do that. There are people that don't do that. I don't like a completely black background. This particular image I'm having trouble with because of this. I want to dim this stuff on the outside, but I don't want to dim this so black that it's completely black, and I'm not sure I'll be able to succeed. But in any case, and as I've been talking here, I've been delaying so I can play with this. Let's make the presumption that this is where we want to go. I just think that background is too black, but I really can't manipulate it well with this donut. This is the real-time preview, so let's close that, and we're going to apply. This is linear data. This is nonlinear data. So we've applied this transfer function to the image, and this is what the image looks like now. We can actually get rid of this, and we can get rid of this. Next step. I always do this. It doesn't take much, and sometimes it has an effect. Sometimes it probably always has an effect, but sometimes you don't see it, sometimes you do. This will help remove a color. Green is not very common in our pictures. So we're going to reduce the amount of green using SCNR. Drop the triangle on there. And again, I didn't see any changes. Let's just undo. Yeah, I'm not seeing any changes, but I always do it. I've never seen it do anything bad to my pictures anyway. And truthfully, you may not, it may have an effect, you just may not see it. So now, you know, the picture, you know, some of these stars have some color to them. But I know that the galaxy itself has some colors. So one of the last things we're going to work on then is some to boost the color up in these pictures. Now this will not be false coloring. This is the actual color that you're seeing. So if people ask, well, does it really look like this? And your answer is, well, yes, but I pumped up the color and pumped up the luminance so that you can see them a little bit better. This is the curves transformation dialog or process. This line in here, you can put multiple points on and move them to wherever you want to change how things look in the image. What gets changed is defined by what is ever selected on this particular row. So red, green, blue, and this is saturation, this is hue. The ones I usually pay attention are saturation, B component, which balances between blue and yellow, A component, which balances between green and red, and then the luminance. Those are the ones that that I deal with. To work on this particular image, we're going to open up another real-time preview. So now anything, I do to here gets applied to here. And the thing I usually do first is to work up on the saturation. It's because there's no color in there. What fun is that? So if I go up here and I grab this point and move it up, you can see that color starts to get added to the image. The stars now have lots of color, and the galaxy itself. And I could take this all the way up to here if I wanted to. This is everybody's taste, and there are people I've seen process pictures that maybe don't look quite like that, not that bad, but maybe about in here. This is one of those opinion things. I don't particularly like that. I do like some color in there, but not that much. So now it's a matter of selecting where I want to put this. And I'm going to pull this down a little bit so that it doesn't go to the rail all that much. It's at 100%, so I want to roll that off a little bit. So I put another one in there. So now I got some color in there, and one that's, we could actually send out or put on Facebook, and people would be amazed by this, and be fine. But we're going to do a little bit more. Let's go, and this is the B channel, so yellow and blue. So if I pull this down, it will make everything bluer. Now the problem is, if I pull it down, then everything starts to get really, really blue. Problem is that I don't really want to do anything with the background. I don't have the background completely black. So anything that I change here, changes the black also. The same thing is true for the red. If I were to do red green and pull this up, everything goes red or everything goes green. And I don't want to do that. I may want to boost the color, but I probably only want to boost the blue and the red in the galaxy itself and not in the background. So what we're going to do, and there's a way to take care of that. So what we're going to do is we're going to first apply this to this image and to get some color all the way throughout. And I'm going to reset this, and then I'm going to make this a line. So what we want to do now is to make a mask. And we do that, make and apply a mask. And we do that with range selection. There's a working preview down here, or real-time preview. Let me do that. It's all white because of the definition of lower limit and upper limit. So as I increase this, and I'm just going to use the mouse button, you can still see that that we got that donut still sitting there. So now we've kind of gotten rid of that. We got the galaxy in here. The difficulty is that our transition from white to black on the mask, from what's going to be affected and what doesn't get affected, is pretty sharp, and that could make a pretty stark change. So what I usually do, at least for this portion, is I'll pull this smoothness up, and that kind of smooths things out. It also kind of eliminates the stars a little bit, and now we're only looking at that. We're going to close this real-time preview. We're going to take the triangle, drop it on there, and it'll make a new image. Let's just see. Make that small, bring that down there. Make a new image called range mask. And now we need to apply this mask to this. You do that by taking this thing, I'm holding the mouse key down, and dragging this all the way over to the left-hand side there. And we've applied a mask. Let me minimize that. anything that is red is protected. So any changes that we make now will only get applied to the galaxy itself. I can actually change this back and forth. There is, I got to select it. So up here are my mask choices. I can actually flip the mask and work on the background if I want. So let's flip it back. And now let's go with this. Bring this back up. Bring up the working preview. And let's say we wanted to pump up the blue a little bit. So I'm going to drag this down. And you can see that, that as I do stuff, it only affects that which is not red on the original image. So now you don't want to, again, you know, that's just way too much for my taste. Now, as I'm doing this, you know, I like the blue it picks up here, but the blue on the edges where it's darker, I don't like that so much. So I can actually make another point here. If I go up here and I click on this, you'll see a line that comes up on the dialog box that tells me where that brightness is. So it tells me if I want that to be a little bit darker, I would have to, whoops, I would have to bring it up, not down. And you can play with this a lot. And actually, this work might be better done in luminance rather than in there. So let's reset this. Let's bring the blue up a little bit. And then we can also work on the luminance. I'm going to put a couple dots in here to hold it steady, and then I'm going to pull it down here. You can see that it's pulling down the edges of the galaxy a little bit to whatever your tastes are. Also going to punch up the red just a little bit to get these what are basically dust channels in the galaxy itself. Let's go with that. Again, this is a real-time preview, so let's close that and then just drop this on there. Now, one of the things I'll do many times to my images is I don't want the background to compete too much with the galaxy in the center. So sometimes I will do some work on the outside. So I've flipped the mask, so now the galaxy is protected. I'm going to open up this preview, and now any changes I make will be done to the outside. There's usually two things that I do. One of them is I turn down the saturation just a little bit. This object is pretty bright, so I don't know how much I would actually do this. Sometimes I'll pull it down quite a bit. So I pull down the color in the stars a little bit. There is one member who likes to see colors in stars, so he doesn't like me doing this. And also I'm going to pull down that luminance a little bit. If I pull it down all the way, you can see that it pretty much takes out the background, leaving the galaxy. So just pull it down a little bit, you know, and we can flip it back and forth. You can see that the luminance changes just a little bit when I do this, but it makes the galaxy itself stand out a little bit more. And I'm really not liking the blue that I have in there, but for now, that's again a matter of taste. Some people may like that, you know, it's whatever you want to do. Let's close the real-time preview and let's apply this. All right, well, I'm going to say that this picture is done. I'm going to remove the mask. That's this icon right up here. If I click that, now the mask is removed. One of the things I should say, should point out to you though, is that sometimes you will not see the mask. There is a button here that will hide the mask. The mask is still applied. And the way you can see that it is applied, if you look over here on this tab, you can see that it's red. And if I take the mask off, it's gone to gray. So now let's assume that we like this image. We're going to save it and amaze all of our Facebook friends with it. So we need to save it, but the problem is that this image is a big file. If you were to save it as a FITS file or a TIFF file, it stays very big, and generally Facebook isn't going to like that so much. So you can save them as a JPEG. So we're going to save as, and you can see that down in here there are different web choices. You probably will see an XISF, which is PixInsight's file format that stores the data in its raw form. But we're going to store it as a JPEG. I'm going to change the name to, maybe since I have one already. And we're going to save it. You're going to get a couple of warnings here. This one says, well, you're storing it in a lossy format, basically. It will reduce the numerical accuracy, but it'll make the file smaller. You're not going to manipulate this file, except maybe to put down a copyright of some kind. We're going to go 80% compression, and then we're going to save it. So the image has been saved. So now, if I do a file open and look at the JPEGs, you can see that there's M33 ABE1. Now, the problem is that it has stored, all it does is store the image in a lossy format. And many times you may say, well, I'd like to go back and work on this image, but I want to get it out of a particular point in my processing. Say, like I say, the blue isn't real good, so maybe I want to go back to that point. So there is something called a History Explorer, and if I open that and I open M33 ABE, here are all the processes we did, and I could go back to where it was after this, and if I double click right there, you can see that the image is now like that, like it was right after we did the SCNR. It still exists down here. I can go back to that, but let's go back to the SCNR value and say, well, okay, I wanted to do the processing from here on. My recommendation is you take this tab and draw it over here, and you can see that it's made a clone. Now, the history for this picture is still there, but now I have a clone to work with, so I can try some different things and maybe do better processing than what I have there, which is fine. But now the problem is, as soon as I close the program without doing anything else, it will lose that history. So if I decided, if I did this one day and then went back the next day and says, I'm going to try something different, well, how do you get a hold of this image with all of its history? The answer is that under File, there is a Load and Save Project. So if you do a Save Project and then define a location, that's a different image that I've been working on. Let's go to here. You can see I have two projects. I could put in P3, and it will save the images, this image, the range image, and the original image, and it'll store all of the history. So once you save it, you can then, let's cancel this because it takes a while to save all that. Oops. Go open that again. What was that? It was save project. Okay. Right, right. It's a godsend. I will say that, to have be able to save this in all the history, because yeah, it just makes life easier and safer. Once you have it saved, you can then load the project. And there's IC10 that I did on the plane wave. Let's go to, there it is. And if I were to double click P1 or P2, it would bring those particular projects up. And it's basically two different processings that I did. I'm not going to open them up because it takes a while to open them up. It takes a while to save them. So there's no reason for you to sit through that again. I think I've covered everything. Mark, can you think of anything that I've missed? Right. You come back and do different things. And in that particular case, you know, we still have, let me bring these over here so they're out of the way. We actually have M33 in here. And we could go in and do a DBE. Oops. Let's just do some real quick so they can see what the effect is. Yeah, you can see that that if these were the ABE values, and what I'm basically doing is adding points for telling the software, use these points to define what the gradient is. And I'm just willy-nilly clicking in here. There's more to this than what I'm doing. All right, enough. Yeah, I know. It's probably something we probably need to do something on. Let's see what happens with this. It may not be. Maybe should add more over here, but let's just see what it is, whether it's better or not. I need to stretch this. Yeah, it looks much better, even with that little messing around. It doesn't have that donut shape. There's still a little bit in here, but it's not near as bad as it was for the ABE. Yeah. Yes, I think ABE is a good place to start. So I can't think of anything else. Mark, can you? Just a second. No, let's hold on the recording. As we've said in the emails, if you want any help, we're around. I spent a couple hours with one of the participants a couple nights back, you know, helping them through the process. So we want you guys to learn how to do this stuff and enjoy the hobby as much as we do. With that, I'm going to say goodbye.